background will handle all the everything else.
Yep. All right. Looks like we are live. Welcome everyone to the first ever Foojay webinar. My name is Pratik Patel. I'm a Java champion based out of Atlanta, and the lead developer advocate at Azul Systems. And we also have Frank and Zoran here. Frank.
Hi, Frank Greco. I'm the founder of the New York Java SIG, and I'm lately doing a lot of consulting with AI and machine learning. Zoran.
Hi, everybody. I'm Zoran Ševarac. I'm a DeepNet CEO, founder of this deep learning engine in Java. And I'm also a Java champion and a professor at the University of Belgrade teaching AI. I'm also a member of JCP EC and involved in many ways in development of a Java ecosystem.
Nice. All right. So we're excited to have this as our inaugural webinar for Foojay, or Friends of OpenJDK. As everyone who has signed up and is watching knows, this is quite a hot topic right now, the intersection of Java and AI. And what we're going to cover in today's webinar is Frank is going to do a quick introduction on AI and specifically how it overlaps with our Java universe. And then Zoran's going to do a deep dive on deep nets, which is a way of training models using Java instead of Python. So we're looking forward to having some great content over the next hour. And we are planning on doing more webinars in the future. So if you signed up for this webinar, you will get emails for future webinars. And of course, we'll put them up on Foojay. But we also invite you to join the Foojay community. If you go to Foojay.io, you'll see that there are some places where you can go and get involved by becoming an author, joining the Foojay Slack, and having a community, large community, actually very large community of Java developers that you can interact with. And there's lots of things that you can do with that, or maybe in the future you might want to host your own webinar, which we're happy to talk to you about. So without further ado, let's dive into the Java and AI part with Frank. Go ahead, Frank. It's all yours.
Thanks, Pratik. Thanks everybody for joining us. Thanks to the Foojay team for running this thing for us. So what I'm going to talk about is just a little bit of setting the table for Zoran. And I'm going to start a little differently. I'm going to start with the takeaways. So normally takeaways are at the end, but I'm going to do the takeaways before the giveaways. So I want you to keep these things in mind as you listen to this presentation, this webinar today. So the first thing is that I think this is something that you all know. You need to learn AI, or your job and career is at risk. And this is not just for us developers, but it's for everybody. The AI is affecting every single industry on the planet. You have to know AI. So learn AI. And what you're going to learn also from this presentation is that Java is a great production language for AI. Certainly Python has its place for in certain areas, and Java has its place. And we know Java is a great production language. Another thing is that models are probabilistic. We are now entering the realm of non-deterministic IT, right? For the past 60 years, we've been doing traditional deterministic IT. We're now moving into a different world. So be aware of that. This is different from traditional IT. Also, we all know that there's a lot of AI developer tools, Copilot, and there's dozens of other ones to use. So you can certainly use AI as a developer's tool, or you're using Java to develop AI. But the important thing is learn how AI and machine learning works first. Once you understand the basics, it's much easier to use these tools, and you use those tools properly. Okay. So way back in the 40s, this gentleman said something pretty profound. He said, the world is composed of patterns. And, if from my perspective, and since I was a closet astrophysicist when I was a younger person, it's the universe is composed of patterns. Now, he said this back in the 40s. So this is a long time ago. And this is the basis of machine learning and AI, is that things are made up of patterns. Now, he wasn't the first one to say this. I mean, I think we all have heard of Bonacci, right? Fibonacci series, right? I think what was his first name? Leonardo Bonacci, right? So he certainly talked about patterns way back when. But this gentleman said it's back in the 40s. And I just added this little QR code. So I go into detail on patterns, which is, again, the core of machine learning. So if you want to go into that, there's a little QR code. My friends at LinkedIn made this course free for a couple of months. So feel free to take that course. And it goes into detail, which is actually pretty interesting. So just to take a step back, we all know artificial intelligence is machines trying to simulate human intelligence. We can argue whether humans are intelligent or not, but that's a completely different discussion. So artificial intelligence we've had for many, many years, where we're writing code in Lisp or in Prolog, we're writing rules in expert systems. So there's a traditional AI. But we're writing code for that. So with machine learning, we're not really writing code to determine patterns, right? So there are algorithms that detect patterns in data. And just as the term machine learning means, the machine is learning from patterns. So there's no explicit code to write for the machine to detect patterns. Obviously, the people that are writing the systems do that. But from our point of view, the machines are learning on their own by looking at data. Now, a subset of machine learning is deep learning. So deep learning is just a modern machine learning. So now we have cloud computing, we have hardware, we have GPUs, we have TPUs, we have AI-specific hardware, we have more sophisticated data structures called neural networks. So deep learning is sort of like a modern version of machine learning. Now, there's two subsets of deep learning. There's generative and predictive. So generative is, I think we've all heard of the generative flavor, is that we're generating things based upon patterns. So there's generative deep learning, and then there's predictive, just as the word says, we're predicting the future by looking at past patterns. So there's generative deep learning and predictive deep learning. But of course, no one calls them that, right? So sometimes we have to bow to the regular press, the conventional non-technical press, and we have generative AI, Gen AI, and predictive AI or predictive AI. So nobody calls it generative deep learning or predictive AI. Generative deep learning or predictive deep learning. So it's generative AI or predictive AI. And of course, I should add a nod to our VisRec JSR that Zoran and I worked on for predictive AI, JSR 381. Now, the two types, predictive and generative, most of the value comes from predictive, believe it or not. So we've been using predictive AI for at least 15 years. So certainly if you've used Google, if you've used Netflix, if you've used Amazon, practically any e-commerce company, you have been using AI. So for at least 15 years. So we're talking about hundreds of billions of dollars in predictive AI. And then just to Google, that's worth about $100 billion. Okay, now generative AI is typically used for more creative, for content generation. We're generating things that are based upon past patterns, right? Now, certainly, Gen AI is the trendy topic right now. The growth and the potential is humongous, right? We all know all the cool things we read about, and all the email that we get from companies about their marketing of AI. So it's huge. And you don't have to take my word for it, but Andrew Ng, who's one of the big names in AI, so he has a presentation. I have the link down at the bottom there. So he has this slide here where we have this big green bubble. So this is predictive AI. And this was like 2023, so a couple of years ago. But so each circle has an inner circle and an outer circle. If you look at the outer circle, 3 years, so that's 2026. We're still looking at predictive AI being way bigger than generative AI. So while Gen AI gets a lot of the buzz, and there's a lot of cool stuff with it, there's no doubt about it. But a lot of the money still is in predictive AI, right? And where to use one versus the other? Because as Java developers, right, we're supposed to be the smart people on the planet. So we have to know where to use predictive AI and where to use generative AI. This is, use the right tool for the right job. So for predictive AI, we're looking at structured data. When we have a lot of tabular data, we have much data, and we want to do classification or we do recommendation systems. Like if you like this movie, how about this movie? If you like this product, how about this product? Right? Fraud detection. You're doing cloud cost optimization. Those are standard things we're using forecasting on structured data. Now, when we have unstructured data, like text, like audio, like video, and we want to generate new things based upon that unstructured data, that's where Gen AI comes in, right? We're being creative, we're prototyping, we're doing translation from one language to another one, right? Or from one data format to another one, or we're creating an FAQ or summarizing something. So that's where we use generative AI, right? And here's just tons of use cases, whether you're doing weather prediction, which we all know has been for decades, that's predictive AI. And then generative AI, we're doing, prototyping or curriculum design. We're matching the output based upon the type of user. So for each use case, you use the right tool, right? Just as like we all know this as Java developers, use the right tool for the right job. Now, how does this affect architectures? Because many of us are architects, right? So we know way back when we were dealing with the web, you've heard probably 3-tier architecture. Some of you maybe old enough to remember that 3-tier architectures. That's when the web first came out. But then what happens today? Our web architectures are so sophisticated; they're far cry from when we got started. But we had to change it to address production use cases. The same thing is going to happen with Gen AI and AI. So as we have generative AI, like a few years ago, we have the simple completion models, right? You send a prompt, you get back a completion. What's going to happen next? The same pattern, right? There's that word again, pattern. The same thing is going to happen. We're going to mix generative AI and predictive AI and traditional IT in the same system. So this is going to happen, and it's happening now. So all of you who are architects now have to change the way you're thinking. You have traditional IT, now you have generative AI, then you have predictive AI, and you use each tool in the right box for the right thing. And for those that are not architects, this is what you have to learn if you want to be an architect, is how do you combine traditional IT with this new AI type of IT? Okay, now where does Java fit in? So let's ask ChatGPT, why should I use Java for production? And of course, we all know the answer. We don't have to rely on ChatGPT for this, right? So here's all the reasons. Java is a great production language. It is, the best production language. We all know this, right? And for AI, if you want to build AI applications in Java, there's a lot of good frameworks and packages. Here's a great one, LangChain4j. Originally started by a Java wrapper around LangChain, which is sort of like a collaboration type of framework, but it's taken a life of its own. It's a great library. You should all follow this repo, and it's a very simple library. Now, for predictive AI, we have Zorn's Deep Nets, and there's the community edition. So we have generative AI libraries and we have predictive AI libraries. So with that, let me turn everything over to Zoran.
Sorry, guys. I didn't unmute myself. So when it comes to using AI models in Java, there is typically 3 approaches. First approach is to use a model as a web service. And with this approach, the advantage of this approach is you can build model in any language, and using model is language agnostic. But this usually comes with a price, with issues with latency and scalability, because if you have many requests in a short period of time, it can slow down. or it can become very expensive and difficult to maintain. The another approach is to use wrappers of existing Java frameworks, existing frameworks, AI frameworks in Python, or to use frameworks that have native libraries they call from Java. This approach provides also its own advantages because they can be very fast. You can code in Java, but usually they don't have Java API, field of Java API, and given using the native libraries, it comes with various memory issues, sometimes scalability, and if you want to distribute it on a very large number of machines, it can be very difficult. What we are getting from people that this approach they refer to, it's a nightmare because it can introduce huge maintenance overhead. The third approach, which is a kind of future of things and where we see Java is going, and what we would like to have is to use Java native AI libraries. That is to use Java AI libraries built on Java. This approach relies on the main advantages of Java platform itself, and it should provide highly scalable, low latency, easy to use platform to build AI, and more important, it will be very easy to integrate within existing development and production environment, and to distribute on a large scale. We had some very interesting use cases with this approach, which was a proof of concept, and people that do have these kind of problems really appreciate using Java native approach. One of the disadvantages of this approach is that for most applications, out-of-the-box models are not available, and you have to build your own custom models, which can take time and require some expertise. Now, when it comes to choosing which kind of library you can use for AI in Java, typically there is a TensorFlow Java API, which is just a Java API for the TensorFlow framework, and it is being developed by the community, so not officially. And the advantages of this is that there are many out-of-the-box models available. It gets out-of-the-box support for GPUs and TPUs with many algorithms and architectures. But as it says on their website, because all the native dependencies for all platforms are distributed, it can be very large in size. And also Java API is not covered with compatibility guarantees. My feeling when I look at some Java API TensorFlow examples is that it requires really low-level understanding of the internals of how TensorFlow works, and that can be difficult for like an average Java application developer. Another approach that is provided by DJL library, built by Amazon, is that they just wrap existing Python-based frameworks. So you have one Java API, and you can build models in either TensorFlow or PyTorch, and you have the same API that is using it. So it simplifies to some extent using these frameworks, and you can use models that are built in these frameworks, but it comes with all the problems that this Java, TensorFlow, and PyTorch comes with. So large size, not covered with compatibility guarantees, and many internal problems. One library that has been out there for a longer time, maybe the first one for deep learning, is Deep Learning4j. It has very big community, and it is being built on top of native libraries for numeric computing. The good thing is that it's very high performance. It provides GPU support and many algorithms and features. But again, it comes with a lot of native dependencies. It is very large in size, and it is to some extent complex to learn in use. In my opinion, and some of the users that we talk to, it is more like Java API on top of some Python framework, not like a Java flavored API. And given all this this overview of existing libraries, the idea and the vision of DeepNets is to create a Java native library that is easy to learn and use. So it can be very friendly for typical Java application developers, and at the same time to make it easy to integrate into existing applications and make it very suitable for and highly scalable for distributing in a large system and providing low latency. Based on our benchmarks so far, I think that we made a good job. It is very optimized, and just doing pure Java, it can achieve comparable performance as some native libraries. The disadvantage is that not all algorithms and not the latest advancements are supported, but we are monitoring the latest development, and for every use case that is interesting enough, the features and the libraries and architectures will be provided. So just a brief overview about the platform itself. What DeepNets provide, it is a deep learning Java library that allows you to build, train, and deploy neural networks natively in Java. Also, there is a visual AI builder tool, which is development environment, intuitive environment for model creation. And we also provide a community edition, which is also a base for development of a JSR, the official standard Java API for machine learning and using visual recognition. And with all that, we also provide professional support and expert assistance for development and production needs. The whole idea is to make AI more accessible, efficient, and easier to integrate and work with for Java-based enterprise systems. And we are doing that by accelerating and simplifying AI development, integration, and deployment. The big vision is that we would like to see the Java platform evolve to meet the modern AI requirements. Now, we'll show you how it works in practice, and we go through typical phases of building an AI model. That includes understanding the problem and defining the problem, then preparing the data, which is a very important step, then building the model, training the model to learn to recognize patterns from data, and then to estimate how good is the model in predicting the patterns and discovering patterns that we are interested in. And as a last step, to use the model within your application and putting it in production. So the simple problem that we are going to go through is to see how to create a model for credit card fraud detection, which is a very important problem, which makes the international payment and credit card processing possible, because there are many fraud situations which are, and it is not possible to create a rule-based system that detects also all of them. So to understand this problem, it's always very useful to put a problem statement in a single sentence. And for this, it would be, given the credit card transaction details, how likely is that it is a fraud? So we want to classify, to put credit card transaction into one of those two folders, not fraud and fraud, with a certain probability. We cannot be 100% sure, so it's not binary, but let's say if it is 80 or 90% probability that it is fraud, then most likely it is a fraud. And we want to build that model using the historical transaction data. So far, we have been talking about the model a lot, and when it comes to AI, the first thing that you are going to look at is the model. And if you're a data scientist, it is perfectly clear what it's all about. There are many different statistical models and mathematical models and so on. But from a software engineer perspective, you can think about a model just another type of abstraction in a developer's toolbox. So, a class, methods, functions, interfaces. Those are all those collections. All those types of abstractions that we are used to. So you can think about a model just as another type of abstraction, like a specific function that you send some data as input, and then you get result as an output. Now, what is interesting and intriguing is how to create those models. And also, there is an approach that many developers take. I just want to use model. I do not care about building the model. It is very helpful to understand a little bit of how those models works and how they are being built, because sooner or later you're going to have some bugs. You're going to have some issues either with the accuracy or in production, and it will be very helpful to understand what's going on, how these models are created, and how to debug those models. So first step is to prepare data, as we said, then build a model, train a model with those data that is prepared. And it is just to mention that it is very important to clean up data and make sure that the data contains relevant information and that it does not contain garbage. So those are three things that are very important to take care of. We'll see in details in the next example. And after the model is being built through a process called training, in which the examples are being presented to the model, and model minimizes the prediction error, then to see how the model will actually perform with some data that it has not seen. If it provides high degree of accuracy of prediction, that the model is ready to be used in production. So the same flow with more details. During data preparations, we usually create training data, which contains data that is used to build the model, and split the entire data set on also one part called test data, which can be like the 30% or something like that of the whole data set. And then after building a model with the training data, we perform the test procedure with test data. This way we are simulating to see how estimating how model is good with the data that it has not seen during the training. So that's why it is important that both training data and test data contain relevant information, enough information. If we get some good metrics, good accuracy for prediction, then we are ready to use the model and we can put it in production. But if that's not the case, and usually this process is not something that you do all at once, like at first shot, then you go back and try to build the model with different settings, with different configuration. And this is iterative process with which you keep repeating until you this test procedure gives good enough accuracy. So to show you how the data preparation looks like typically, I will use the library called data table saw. It is a very good library for data frames. Basically, what you have in Python pandas, this library that everybody is using for storing this CSV tabular data. In Java, you have table saw, you have EC collections, and you have dflib. All three are very good. I looked at this table saw. It was very nice for this demo, easy to and readable. So reading CSV file, because usually when you get the data to train a model, you can, of course, get it from a database or anywhere else. But most often you get from a CSV file. And what we have here is that we have a credit card CSV file that contains all the information about transactions, and going through builder and reading data into data table. So to simplify, to hide the details and make it easier for you maybe to do the same thing, I have created this class called data preparation, which contains typical models, typical methods that the data scientists apply to data. And the first thing, of course, when you load the data, is to just preview rows to see what's loaded, then to see which columns you need or you don't need. For example, in this data set, we don't need column time. Time is not relevant for predicting if the transaction is fraud or not. Then we want to remove duplicate rows. Then we see if there are any values missing, and examining basic statistics to see if there are any outliers, if there's anything that's not how it should be. And that way you discover maybe some anomalies or errors which can make training process very bad. One of these things is to check if data set is balanced. And just, for example, in this case, when you look at the data, you'll see, and this is typical for these fraud detection problems, you have like almost 300,000 transactions which are not fraud, which are legit transactions, and you have only 400 transactions which are fraud. Now, if you use this kind of highly unbalanced data for training a machine learning model, what you'll get is probably a model that is very skewed, and you'll get the 99% of accuracy or 100% of accuracy, but it will only say that the transaction is not fraud. Basically, if you say the transaction is always a fraud, you'll be almost 100% right. The reason how do you solve this is that you randomly sample, we downsample, we just take 400 transactions that are not fraud and 400 transactions that are fraud, and create like a balancing data set. So I will show you how this looks. You have this entire demo on a GitHub. So this is the data preparation class with all these methods, and I'll just run this. So what I show you in the slide, reading a CSV file, and then checking. You see, this like a visualization is performed by data frame. You can see how this data set distribution of fraud and not fraud examples is highly unbalanced. And after balancing data set, we have the same amount of these not fraud and fraud transactions. So this is just a one method call, you know. You see, check class balance, and it tells you here it ran entire training. Let me show it also completed. So this is the output, reading the structure of the file, then looking at what are the tables, the columns in the table are. We see this column time, we remove that column, then we check for missing values. There are no missing values. So this is basically workflow that typically data scientist does. This is kind of various statistical summaries for entire workflow, and positive class, which are frauds and which are not frauds. You see difference. And after the balancing, we get a nearly the same number of both of them. Now, after that, let me just go here. Well, this is kind of data scientist part of work. And after that, once we have a balanced data, we create another type of data set which is suitable for training neural networks. This is data frame. These are columns, a map of columns, map of lists. But when working with neural networks typically work with tensors, which are densely packed arrays, multi-dimensional arrays. So there is also utility method to convert table saw data set into a DeepNet's tabular data set. And then another kind of preparation is to prepare data for training for neural network, which is to scale all the values in data set to range of 0, 1, because those kind of functions are used, mathematical models are used inside neural networks. And the last step is to split data into training and test set. As you remember on those diagrams, we have again this utility method, train, test, split, which does the job for you. So we get a training set and test set. And you see that we designed this API for DeepNets and JSR and this utility tools, we try to make it very simple and very intuitive for developers to follow this kind of workflow and with just a high level understanding of what needs to be done. Then when we're talking about building model, we are going to build this like a kind of basic kind of model, which is base for even the most complex generative AI models. It is a feed-forward neural network, and it is being trained with an algorithm called backpropagation, and you get all of that out of the box. So you don't have to be expert in math and machine learning in order to be able to use it. You just need to configure the model to understand that this model is created with a sequence of layers, that at an input layer you have a specific number of inputs. Okay, you say I had input layer and how many inputs. Then you get this kind of fully connected layer, which contains certain number of these computational units called neurons. And then you specify how many of these units are going to be used to divide this feature space. This is the main, let's say, brain of the model. And at the output layer, this number corresponds to the number of outputs in your data set. So pretty much input and output, these values, it maybe look difficult to configure and set all these parameters, but it's actually not once you understand it. So number of inputs, size of input layer corresponds to number of inputs, size of output layer to size of outputs. And since we are doing like a binary classification problem and classifying things into two different classes, true or false, or positive or negative, what we need is this activation sigmoid function in output layer and this loss type cross entropy. This is the error function which is used for classification, binary classification purpose. Now, two parameters that you probably need to experiment is the size and the number of these hidden layers and this activation function. It's a whole different philosophy and could take another webinar to go into details. So I'm not going to do that now, but if you're interested more into optimizing these neural networks, you can write us and we'll prepare some for future webinars. Now, to get a training algorithm for a neural network, you just need to this get trainer, like that is implementation of backpropagation algorithm, and then you have to configure it specifying this stop error. That is the error when the algorithms will stop training and consider that the error is low, that it does not require any more training. If that doesn't happen, then you want to limit number of epochs. And one parameter which is important is to set like a learning rate, which is like a step size for adjusting weights, because the training is an iterative process, and with each iteration it changes the internal parameters a little bit, and this is the percent of error that is used to adjust these internal parameters. Now, in order to start training, you just invoke train method with this training set, which is set as a parameter, and the entire training process, this is like a pseudocode. Now, while the number of epochs is smaller than the number of epochs to stop, and error is higher than the stop error, then you pass all the examples in training set, calculate prediction for specific element, for example, for its input, and then calculate prediction error and tune the weights or those internal parameters of the neural network in order to reduce error. So to see how the training looks like, DeepNets provides logging as any decent Java application with each epoch, specifying training error and accuracy, and also the training error change. So you can see how with each epoch the error is lower, and the accuracy is getting higher, and it gets low very quickly, but it takes some time. And you see, it quickly goes down, but then it slows decreasing error a little bit, but in some kind of 500 iteration, it gets to 0.96%. This is because I limited, we could make it trained more, But in order to, if you must take care, if you take too many iterations, then you may overfit. And those are typical problems when it comes to training neural network, because sometimes you can get a situation that error is increasing during the training. Then what you need to try is to lower down the learning rate, to try the smaller learning rate. But if error is not decreasing after even many training epochs, then you should add more hidden units or more layers, because it means that the model is not complex enough. The data are much more complex than the modeling capabilities of the model. And the third typical situation is that model gets very low error for training, but you get a very high error with testing. That means that the model is overfitting, that it managed to catch noise. So it is too good. It's handling unimportant details, and which makes like a wrong prediction for the main properties. So this process can be time consuming and also error prone, and sometimes it's difficult to keep track of everything and try everything. So there are tools. Every framework has different tools to do that. And for DeepNets, there is a visual AI builder tool which helps you to run these kind of experiments and tune these settings in order to solve this problem. Now, when you create a model, the important thing is to estimate how good is the model. So what we're doing is we are calculating various evaluation metrics. Basically, we are testing. So it's not typical unit test, but it's a kind of testing in machine learning. So we are performing test method invoking with a test set. And it calculates all the various evaluation metrics, which are listed here: true, positive, true, negative, accuracy, precision, or we call F-score. Now, if you're not a data scientist, this might look like awkward to you. And what is all this? So DeepNets, besides just putting all these values, this explains what every of these metrics is. So, for example, accuracy is how often is a classifier correct in total, so percent of total correct classification. And precision is how often is classifier correct when it gives positive prediction. See, it is very high, 0.98, even higher than accuracy. And recall, when it is actually positive class, how often does it give a positive prediction? So it is always a game between, balance between false positive and false negatives. Those are missing. So when number is, it is a number of examples incorrectly classified as positive, and number of examples incorrectly classified as negative. So these are mistakes that model is making. So in order to find the right balance between those two, these metrics, F-score is used. So this is kind of harmonic average of those two. So there are various ways that we are trying to make it easier and more intuitive for developers who are like a kind of transitioning or somewhere in between the the software developers and machine learning engineers, and kind of would like to play with it to make it like a more intuitive in terms of software development workflow. Now, when the model is trained, this is how to use it. So what we want to be able in production is to ask what is the probability that a given transaction is fraud. So we just have this model, this neural network, and we invoke predict method, and we provide an input tensor, which is kind of array of the features of transaction to get the output prediction. And if the prediction, as a result, we also get a tensor. If the probability is higher than 80%, we say there is a high probability that this is fraud. So this is all fine, and we try to simplify it. But the reason why we created this JSR 381 is to make it like a more like a Java feel of this API and more intuitive what the code is doing. So we don't want to work with tensors either. It is not complicated concept like a multidimensional array. And probabilities, we just want to invoke classify method and get like a float probability. So this is what like a binary classifier. This is the implementation of binary classifier with feed-forward neural network from deep nets looks like. So we basically wrap this model into this classifier and use it. This is like one implementation of a binary classifier. This makes API calls like a model independent and library independent. And there is even DJL implementation of some of the main methods from this JS from this API from JSR3AFY. So this method that I just told, if you're interested in credit card fraud detection or other, it is not the only solution. Usually what's being used in practice and what several papers are out there is that they are combined with other traditional statistic and traditional ML methods like logistic regression, decision trees, random forest, and XGBoost. These are basically all second decision trees because they're expandable. One problem with this deep learning is also it can achieve higher accuracy. Sometimes it's difficult to explain them, but in combination, these two can make a good team. And this is called so-called ensemble models, in which you're creating a group of models. And if you want to do that in real time in production, then they need to be very fast. So the types of models that are used for deep learning, besides these feed-forward networks, also autoencoders, which are like a special case of feed-forward networks, then convolutional networks, which are also supported with by deep nets, LSTM recurrent networks, which are not popular these days, but also transformers are being used, and this is under implementation with deep nets. So if you want to take your Java AI projects to the next level, and if what you heard today sounds interesting to you, then we would really like to hear what are your needs, what are your thoughts, what libraries or tools you're using and why, what challenges are you facing for building and deploying your models, and if we have some interesting projects that you are working on that we would like to really hear more about it. And we, besides just providing library, we provide also expert consulting for AML solution design and integration in Java. We are interested to learn together and to optimize AI models for production environments, and more important, scaling AI across the distributed Java systems. So what you saw today, this demo is available on this GitHub repo, full source code, including this data preparation techniques. And you can download the latest DeepNets, which is free for development, prototyping, and education from the following link. And since there was quite a lot of interest in this topic on LinkedIn, we decided to create a LinkedIn group, AI ML for Java ecosystem, and we would like to invite you all to join. And in order to prepare the future webinars and provide the content that you are interested in, consider taking this quick survey. There's just 4 questions that will really help us to provide a good, interesting content for you. So I will leave this transfer it to Pratik. Pratik.
All right. Thank you, Zoran and Frank. We have some questions from the audience. So the first one is from Kay Hortzman. He asked or says he's confused about the wrapper around Python-based frameworks. I'm sorry, this may be for Zoran. Yeah, I'm confused about the wrapper around Python-based frameworks. I thought Python was a wrapper around C++ code. Does the computationally heavy work, is a Java library going to Python or C++? I think that's a question for Zoran. You mentioned this earlier.
Yes, well, it's not. It's a wraparound. It goes to C++ actually. Python is just the API to build the models, but the main power engine is built in C++. And this DJL provides unified API to talk to load the models, created with TensorFlow Python API, but it runs on a C++. So
okay, got you. And there was I think a similar question from Sheikh, who was asking about the overhead of using JCUDA in place of CUDA. Are you familiar with like the difference between those two?
Well, to be honest, I didn't run like some huge data set, but I think the overhead is very small. I think I get like with very large convolutional networks with like VGG, I get 10 milliseconds for inference. Which is quite comparable, maybe if not as fast as doing it with other frameworks in C++. Maybe if there is more data, it could be slower, but I doubt. And because DeepNet provides support for importing TensorFlow models, and we also use JCUDA for inference, and the overhead is very small. We are looking into implementing the CUDA binding using Panama, and we have started working on this project. So I think that would be interesting to see.
Okay, great.
Actually, I wanted to clarify. So Kay's question, Zoran. So that was not his question was not about the DeepNets library. That was about DLJ or some other library. Just wanted to clarify that.
Yeah, but the second question was about CUDA, JCUDA and CUDA.
No. The first question with Kay about wrapper around Python frameworks. It's like, which specific library was that question about? Which
DJL.
DJL, right?
DJL, yes,
right.
yes.
Just want to clarify that.
Yes,
yeah.
Yes.
Kay has a follow-up question. He said, you talked a lot about classifiers, credit card. Is that what people mostly do these days, or is it more interfacing with Gen AI? I think, Frank, you can probably take that question. Again, the question was, Zoran talked a lot about classifiers. Is that what most people mostly do these days, or is it more interfacing with Gen AI?
Oh, I don't think what Zoran was talking about was interfacing with Gen AI. I'm not sure I understand.
I think this is more of a general question, Frank. Basically, it's what Zoran talked about was predictive analysis and classifiers,
right?
And Zoran's asking, like, are people doing more of the predictive analysis AI, or are they doing more of the Gen AI?
Right.
Well, I think it's a more general question.
Yes, right, and that's a good question. And from if you watch that talk by Andrew Ng, he talks about the revenue generated from AI. Where's it coming from? And right now, it's coming from predictive AI. It's not coming from generative AI. We hear a lot of the buzz and a lot of the promise, but the real production revenue is coming from predictive AI right now. So, and that's, I mean, Wall Street has been using predictive AI for a long, long time. And certainly Amazon and Google have too. Can you use predictive AI for some Gen AI applications and vice versa? Well, this is software. We live in a software world. Of course you can. It's just that, what is your pain threshold? Are you using the right tool for the right job, right? Can you use Python for Java things and Java for Python things? Yes. But what's your pain threshold? That should be the question you should be asking for, not whether you can do something or not. But certainly, Kai, what you're asking about, with Gen AI right now is for a lot of creative stuff, right? And that's what it's really good at, creative stuff, or doing like zero shot type things like translations. I mean, it's really good at language translations. It's really, really good at language translations. If I was a language translator right now, I'd be very worried about my job.
Yep. So there's also this question is a little bit different. This for Zoran. He asks, this is Gabriel's question. He's asking, what would be main difference between usages of deep nets and Spring AI instead of it? I'll take this one. I'll take a crack at it, Zoran. You correct me if I'm wrong, okay? So Gabriel, in this case, we're talking about basically two completely different things. Deep nets is more for training models and building models, whether it's for predictive analysis or whatever. Spring AI is, at this point in time at least, it's more for consuming generative AI models. So they're like two completely different things. They don't, you could probably use both actually to build a solution, but they're not the same thing at all. So they basically solve two different problems. Does that sound about right, Frank and Zoran?
Perfect. Yes.
Yep, exactly.
Yeah. Okay. There's someone was asking about Kai. Sorry, Kai has. Sorry, I mispronounced your name, Kai. He's got a follow up there. Do Java programmers get into the weeds like Zoran showed with these model parameters, or is that the job of the specialists? He's specifically asking about predictive AI. Yeah. So Frank just put the question up on the stream for us. I'll let you take that one, Zoran, and see if we can answer that question for Kai.
Well, it depends what of a specific person. I think I cannot say general. Those developers that do not want to get into the details, they don't have. They just get like a high level task oriented API from JSR and just call, say, classify things, load the model and classify things, or invoke web service or whatever. But as I said, usually it is very helpful when you understand a little bit more what's going on. And I just looked because I think that there is question going on. What should be AI for Java developers? Should be only using model or should be building model? I think one does not exclude other. I think there are developers who do want to only use, and that's perfectly legit. But there are developers who want to be able to build and understand the models. I think in a recent survey by IntelliJ, there's like about 20% of software developers transitioning to machine learning roles. So not just when say, hey, I'm a Java developer, I'm just going to write, talk to database and that's it. But I can build more. Java has been used in academic environment for a long time. There are many other libraries and frameworks, and I think it would be bad for Java as a platform to leave that space, because it used to have a very strong position there. We just need to put some pieces together and make it more easier to use. I think with these new APIs and the developers with the Java platform like Vector API and Panama, it will be, things will significantly change, and that will be very soon. It's not enough. We don't only need platform features. We need the entire ecosystem to develop, and like libraries and tools, and we need to make it easy for application developers to easily build specific use cases. So it will take some time, but I think it can be faster than people expect.
Also,
Yeah,
if you're using the higher level, the JSR, some of the model parameters, I mean, certainly Zoran went into a lot of the details of that, but for some of the image classification, you can use a lot of the standard configuration. I mean, I have a repo that does specific pictures of certain dog identifier, and I didn't have to go into the low level details. I just used a lot of the like out of the box type of configuration, so that worked pretty well.
Yes, there is you can say model.build and that's it. But yeah, you can always. But if it works, then perfect. But what if it does not work? And more important, how do you know if it works or not? Because most often when you get a model, how do you know that that model will work? You need to evaluate it, and you need to understand a little bit about the evaluation. You can say, okay, data scientists will do that for me, but it's another story.
Yeah, so there's a specific question about deep nets, which is this is by Scylla Zanto. I apologize if I didn't pronounce your name properly, but he's asking, what about the training input data size when using deep nets? Any upper limits?
Well, actually, we have managed to train, not us, but one of our users, this Department of Energy, US Department of Energy, Jefferson Lab, which has huge data science experiments from nuclear physics. I don't know the exact size, but quite large distributed system was used, like 2,000 machines was run, and it was only on CPU. So if you have enough computational power, then actually there are no limits, and it is very simple infrastructure. It does not require all the Dockers and the images. You can just use the basic plain Java to do that.
Okay, and the next question is for Frank. Someone's asking, currently Python dominates the AI domain. Are there any future bottlenecks if we use Java native AI libraries? This is a good question.
Yeah, it's a very good question. Certainly in the AI ecosystem, Python is fairly ubiquitous. But if you look at how, I mean, patterns, that's the key word here. For quick development, I mean, there's no doubt Python has an advantage over Java for quick development, for prototyping, for building things, for showing investors applications. That's its forte, right? But now to put things into production, I mean, and if you look at where we are with generative AI, right? We went through a prototyping phase. People are building cool things. Now, then we talked about agents and all that stuff. Now, how do you put this in production? That's the big question. And that's what all enterprises are now, not the past 3 years, but now are dealing with. How do we put this in production? And this is where Java comes in. This is perfect timing for Java. So, because we know how to put things in production, right? So we have these models and we have these frameworks. So now let's combine it. So it's not like, if you look at it like, well, Python's been doing it. Well, that's great. Python is a fantastic language for prototyping. But now we put in things in production, and that's where Java comes in.
Yep. So let's we're at the top of the hour, so let's close this out. Frank, there was a request for the LinkedIn Live course that you mentioned. So if you don't mind, drop that in the chat when you get a minute, so we got a record of that and people can go peruse that. And finally, we'd like to thank Zoran and Frank for coming on to the Friends of OpenJDK webinar. This is our inaugural webinar, so it's we've had lots of people joining and lots of great questions. Check out the Friends of OpenJ community here. Of course, you can become an author, join our Slack channel, meet other Java developers from around the world. And of course, this is YouTube, so like and subscribe, as they say. So please subscribe to our YouTube channel where we have other Foojay folks who put content out here. And of course, Foojay is a community effort. So you are most welcome to join the community, write some articles. And if you have an idea for a Foojay webinar in the future, we're happy to work with you and put that on. So big round of applause, or virtual round of applause, I guess, for our two guests today, Frank and Zoran. Thank you guys for coming. And we'll see you at the next webinar. Thanks, everybody.
Thank you very much.
Bye, everybody.
Thank you. Bye, everybody. Bye.